Okay, so this is diagnosing and treating brain cancer or brain infections with nanoparticles. This is UTech O, Nicholas Segovia, and I'm Ryan Jameson. So the types of nanoparticles used. Various different nanoparticles were used in the article, including lipid-based nanoparticles, metal nanoparticles like gold and silver, for example, silica-based nanoparticles, and zinc oxide nanoparticles. All of these nanoparticles varied in size and shape with no specific descriptions. The image on the left here is of the different nanoparticles and nanomaterials used to detect and diagnose various brain infections such as meningitis. The gold and the gold nanoparticles were almost cubic, and the zinc nanoparticles as well. And then they also used vesicles that were spherical shaped, and then a carbon nanotube. So application of the nanoparticles. So all of the research done in the articles was based on clinical trials done on animals. Specifically, rats and mice were the test subjects. The results were promising and no harmful side effects were observed in these animals, but there are still many concerns about the safety of nanoparticles being used on humans. The next step here is human trials to determine if the results will be the same and if they're safe to use on humans.
Application of the nanoparticle. In the article, nanoparticles were being used to treat and diagnose different brain infections and issues. The main focus was on meningitis, but applications for cancer treatment and tuberculosis were also mentioned briefly. Brain infections are extremely harmful and need to be detected as early as possible. Meningitis is, if not treated properly within 24 hours, is extremely fatal. Current practices have many flaws, so the promises shown by nanoparticle research on animals could be proven vital to the future treatment and diagnosis of these fatal infections. What exactly
What exactly do nanoparticles do? There was a great focus on using nanoparticles as vessels for other drugs. There's a great challenge when it comes to hydrophilic and hydrophobic drugs crossing the blood-brain barrier. Nanoparticles proved very effective at crossing the blood-brain barrier. Gold nanoparticles were also used for different treatments such as photodynamic therapy, in which photosynthesizing agents are paired with light are used to kill cancer cells. Gold nanoparticles are also used to induce metallic hypothermia, in which gold nanorods along with the constant laser of 808 nanometer proved to be effective at treating glioblastoma brain cancer. This image shows how nanoparticles act on certain cells of the brain to deliver drugs for the treatment of meningitis. Explain the picture.
How does this improve upon the current technology for this application? There are many different methods of diagnosing and treating meningitis, brain cancer, and other brain infections. But despite their success in preclinical uses, they have struggled to succeed in real-life situations and applications. Many of these methods have rendered indeterminate results or take so much time that it is too late when the results are processed. This is where the need for nanotechnology comes in.
How does this improve upon the current technology for this application? Nanoparticles and nanomaterials are drastically improving on the current methodology's weaknesses. Nanoparticles have been shown to increase the concentration of the drug they are used to carry in the brain. Nanoparticles are biodegradable, non-toxic, easy to synthesize, and have a high surface to volume ratio. Brain infections and diseases are highly complex. Currently accepted practices for diagnosing these problems are often ineffective or too time-consuming. This has caused the need for new methods of diagnosing these diseases, and nanotechnology has proven to be very promising. Here are references for the one article we used. And then here's our quote. To date, much of the work in this area has carried out in different animal modules. And the next important move in pushing this area forward is to efficiently work in clinical trials, thus resolving any possible non-toxicological concerns.